All right, thanks everyone for joining me today. My talk, Unit Testing Apps with Ease. My name is Dwayne Newman. I'm a Microsoft MVP, a software developer consultant with Alien Arc Technologies, my company. We do custom software development for other people and try to create some cool things in between. You can follow me on Twitter at Dwayne Newman. And that's all the time I'll take up telling you about myself. So if I can get switched to my PowerPoint here, there we go. First, want to bring up the sponsors for Code PaLOusa. Great that given all the situation that we're in today with doing online conferences the way we are, that we still have people willing to sponsor and help us make it happen. So I want to get started talking just a little bit about common unit testing challenges. And this talk is Unit Testing with Ease is really all about making our unit testing easier. And again, as I begin to notice some of the challenges out there for doing unit testing, and there's kind of three major areas that I want to talk about and go through. First one is working with APIs. A lot of times we might be developing an app or front end for something. I've done a lot of XAMARIN work and might be creating that mobile app and not actually have any back end written yet. It's greenfield. There might not actually be an API. Even brownfield sometimes. They're having you do new things to integrate, and the integrations might not actually exist. So challenges are working with that not only from your app, but also, from your unit testing perspective is, how do I test something that needs to go out over HTTPS? Or HTTP? How do I deal with that without actually having to have a server and a server set up with all the right test data and everything else? I need a unit test I can run just in the code and make sure that my code does what it says it does. But some of those things might actually involve going to the outside world. So I'm going to talk about some ways that we can deal with that and how we can get around, having to have live systems and be able to still actually validate that code. Next thing is, injecting dependencies. So, as your services or view models or whatever other part of your application, different modules grow and expand over time, the dependencies that they tend to bring in also expands with it. And so you might find yourself, with an ever-growing list of, constructor parameters or, whatnot, to actually just be able to create the thing you want to test. And not only do you actually need to get those things in there, but, they need to work properly as well, going back to talking about doing the APIs and things. So we need to be able to have a way to actually get, all these dependencies into our system in a way that we can actually work with it. And that makes it easy to maintain the test as well. So every time we had something, we're not going and updating, dozens or possibly hundreds of tests out there to update, constructor signatures and things like that. And then the other part is instantiating objects, trying to get away from new, just like new in your actual, production code can be problematic and everything, not being able to inject those things, but, directly calling up your concrete implementations of stuff. It can also make your tests become very brittle. I already kind of hinted at it with the injection dependencies point, but dealing with a signature that changes over time and everything. If you're newing up the thing you want to test with actual new keyword and passing all the things in, each time you touch that signature on it, you're gonna have to come back and update all those places where that happens. And you're gonna have to deal with creating that entire dependency chain, getting all the pieces out there and moving it in there. And it's stuff you just don't want to have that in your tests, right? We don't do it in our apps. Our apps are pulling this out. You're doing, some sort of MVVM, UI, or you're doing ASP.NET, other things like that. They all have dependency injection being done that gives us the things that we need when we ask for it. We don't have to go there and actually, create all these things and stuff. So if we don't have to do it in our actual code, why are we doing it in our unit tests? And how can we get away from that? So the first things I want to talk about, first point, is APIs, and really working with APIs when you don't actually have an API. And this has benefits for two reasons. One, for being able to unit test your code, in an enclosed environment where you can control everything around about it, and also being able to, actually take this and maybe put this into your actual app as you're developing, and be able to stub out API stuff in a way that makes you not actually have to have those APIs exist either for app development. We'll kind of go over that a little bit as we go through it. So the heart of getting away from actually having a real API server is to look at the HTTP message handler. There's a few different ways to do this. I actually need to update some of the pieces on this, but we'll talk about one that works here. But to replace that message handler with something, so the message handler is the actual part of the HTTP system, the HTTP client system, that does the real work of requesting a message and actually, going to the server, getting it back, returning a response. If you look at what HTTP client does, really pull the code apart, it just says, hey, I've been told to go ask for something, and it kind of composes some stuff, and then it says, okay, hey, message handler, go get this and return me whatever the response is. Send this message and return the response to it. So it takes in a HTTP request message and returns back the HTTP response message. So the default implementation out there, if you look at HTTP client, is HTTP client handler. That's what does the normal stuff, but we can specify this on creation of the HTTP client to do what we want to do. And so how I've done that is I found this great project out there, mock HTTP, by Richard. I'm not going to try to say his last name because I'm sure I'll butcher it whichever way I do it. But he's created this great mock HTTP NuGet package project out there that has been really great with the making HTTP responses and requests easier to handle and deal with. So it provides a custom message handler that we can give to the HTTP client, and it allows us to define the things that we want to respond to. So if we respond to a message of some sort, we can specify the URL, all these things that you mock what comes back to it. So here's a little bit of example of how it works and what it does. So basically what's happening here is we can set up a couple things. So this first line here, we see we're actually setting up a static response on it. So it's saying that, hey, when I get a request for HTTP localhost API user, and then anything after that, I want to respond. And it's got some helper methods here to create your response message, but I want to respond. I want my media type to be application JSON, and then I want my content to be this string. And so that's static response. Whenever this comes in, that's exactly what's going to go back to it. And then you can create a dynamic response, which says, in this case, we're using the expect, and we'll talk about that in a minute. But we're using the expect to say, hey, when I get that same URL we just talked about, I want to respond, but I want to actually do some code here. So give me the request that's coming in. I'm going to take that request. Now I can look at the request. I can do things on it. We're doing something very simple here. Our ID is the last segment of it. So we're just taking the request URI, taking the segments, getting the last one, and then we're going to return a HTTP response message. We're going to say, okay, and our content's going to be some new string content, and we're doing a little bit of magic here. We're giving back the same name, but we're giving back the ID they passed in so that we can create a response that matches the request coming in. And so you can imagine there's really kind of a lot of possibilities as you get into this with what you can do on it. And so just take a little demo at it here. Let me switch over to here. Okay. So here we have the package included in here. I'm just using LinkPad. And let's minimize that over the side there. So here we've got our host set up. We're creating the mock HTTP handler. And then we're just going to tell it here that, hey, when whatever my host root is comes in with something, I want to send the static content back. So we put this together and we just run this. We can see down here that our static content comes back just as we expected. ID, 0 name, static user, all great right there. But if we want to do a dynamic response, we can set things up in our class here. We can give us a list of users, and we can come in here and we can actually inspect the request and come in and say, hey, we're expecting to get this request in, and when we get it, let's do the things that we just talked about right here, right? So we're going to pull it apart and read through it. So if we run this with everything on here, we see a couple things have happened here. One, because we use the expect keyword here, you'll notice, so we did our setup, we did a response, and we got what we expected, to have there. We told it here, hey, I expect to see this URL come in, and when you do, process the request and come through and spit it back out. And then we request 2 different users here, 2 and 1. And you'll notice in the output that we went back to the static response. And so the nice thing here is you can actually set up a series of actions that you expect, just as it says, to happen, calls. And so you can set them up and say, I should get these calls, and it goes in reverse order of what you've set it up here, but it goes through and says, I should get this call. And when I get it, do this. And then now I don't expect it anymore. I go back to whatever the next piece down is. So if we change this to a win, change it to be the win. This is the default handler for it. And now we've called it twice down here. And for each of those is returned the data on it. But we can do fun things like come and take this code down here. Switch this to an expect. And then let's add a third call in. Now we see that, call right here. We see that we get the static string back for this first one because of the expect, and then it falls back to default defined one there. This is a really simple, example of it in action, but it's really very capable, and this has been, a great lifesaver when it comes to actually doing the development testing of API calls and knowing that stuff works. So now we have that set up. The question is, how do we use this? How do we make use of this in our our code. So there's a few different ways of doing it. This is one way I've done it in the past, easy way, and that is, interfacing some things out. There's some cleanup I need to do on this for dealing with HTTP client these days, but this will still work. Basically, we create a message handler factory and implement it, a default one there. So this would be the default handler that you're going to use for regular application usage. And then your service just says, hey, I need a message handler factory, and then creates a client with a message handler factory and passes that in, gets whatever it is. So in this case, it gives it our default usage. Obviously, so for unit testing, we would create a message handler factory, a mock one, that defines our API in it, maybe has methods to do setups for different kinds of scenarios, or exposes it so that we can set it up inside of our test to do things outside of the normal on it. But we can set it up to have a known set of data, a known set of responses to certain kinds of requests, so that we can test our services, make sure that when they're making their HTTP calls and processing the return results out of it, that it's getting what we expect. You can also do things like return exceptions, obviously. So you could return a 404, 400s, 500s, all sorts of different things back to it, and test that your service code responds the way that you would expect it to respond and does the things you would expect it to do. So very, very useful, very helpful. I think, if you're doing anything that's using API work and you want to work with it, this is really a good way to do that and actually test those pieces that do it. And you may have those abstracted out to where it's a really thin layer that does the actual API calling and feel like, okay, that's good enough because it's just doing a really simple, JSON conversion of data coming in or something or whatever, and then passing it back up to the next layer. And that may work for the most part, but really at some point you want to make sure that, those things do what you expect when they have a error condition or something else. And it's really hard to test without having something set up. So maybe your implementations for the API in your, mock handler is really small and just covers, the things that maybe your adapter that's going to your API calls and everything needs, but gives it the cases you want there. So I hinted at this before, but some bonuses to doing this is that you can use this wherever. So it works great in unit tests, but if you're proof of concepting out something and or doing development on, like I said, something greenfield where the APIs don't exist yet, but you have some agreement on what the APIs are, or maybe it's a third-party service that the API surface for, but you don't have stuff provisioned in it yet, or a license to it, or whatever it is, and or it's really hard to make sure that your app, the UI of it, the actual user experience of, say, a failure or something, is what you expect it to be. And it's really hard to just pretend those things out without doing something special on your server or whatever else. So this gives you a way to actually be able to provide HTTP content back to your actual application code that will make it behave the way you want it to. So this is really great. We've used it a bunch of times in projects where we kind of need to put some things together. We didn't have the stuff there yet, but we needed to actually build screens out and make sure that the in-between pieces, that everything we could control was working right and was doing what we expected. And this got us a big step up on it. So, and since we already defined things for the testing, it was easy. We were just able to pull that reference over and use it in our app during development. Very, very helpful. So the next really big thing I want to talk about is dealing with dependencies. And, so testing, one thing and not all the things is really what we want our unit test, right? We don't want to have a unit test that's doing integration testing with all of our whole system, we want a unit test that really just tests that this one thing behaves the way we expect it to. We should have a test for the other thing it depends on that it behaves the way, but for this one thing, we want to make sure it behaves with a known, response and everything. It behaves the way that we expect it to behave. And so figuring out how to do dependencies for all this without it. All the different pieces that we have as a, standard MVVM app of some sort. You're going to have, view models and, repositories and APIs and navigation and all these different pieces that, each need to work the way you want them to work independently, together, but need to be able to test them independently and make sure that it all works. And so there's a couple ways you can do this. I like to use mock, MOQ, pronounced mock or mock-u. Their site actually says you can say it either way. Another popular one out there is in substitute, and I've used it some as well. But I like mock just because, if nothing else, it was kind of what I got into mocking with, and I understand it really well. But it's nice because, you can lay everything out in a fluent syntax, so it's very easy to build out your behaviors on it. You can mock both interfaces and classes on it, and then provide you not only access to the object you're mocking, but you can also get back to the actual mock itself, the mock instance, to do setup or to do other validation calls to it, even if the only thing you have at the time is the actual mocked object that it gave you. We'll look at that. It has a lot of ways to do your configuration and do call matching and stuff on it. We'll take a look at, and you can, just like with the HTTP mock HTTP stuff, you can do either static responses out of your mocks or dynamic ones based on the input coming in, or dynamically static, if you want to say that. Static in the sense of returns a known set of stuff, but dynamic in the sense of one API call can be called, or I say API, one code, one service call can be called multiple ways and return the expected result based on what was called into it. And I also like it because it's strongly typed, so that you know that when you refactor, it's going to catch all your mock usages and stuff out here as well. And you can kind of change it up on the go while you're running through tests. You can change how it behaves. So here's a really simple example of it, how it works. So we're just defining a mock of the iCart repository. And so this is not, the mock here is not going to be the actual iCart repository we use, but it's going to be the whole mocked piece here. And so we can see we can do setup down here. So we can expect certain things. So in this case, we have a clear all products method call on it. So we're telling it we want to configure that clear all products call, and we're going to do a static result, and we're just going to return a empty array of the cart product. And then we have the carts here. So this is a dynamic response. It's taking our cart object, turning it into an array, and returning the task result from it. So this is a task async task interface here. So, but it comes in, expects it, and so it's actually doing work. So this is going to be evaluated each time. So this is evaluated once, and this task is created at this point and just sitting there, and we're just going to return it every time. This one, every time it gets called, it's going to run the Lambda here to create the response back for it. And then we can do more advanced things on it here. If we update a cart, we expect to get a parameter in. So you can set this to be a specific thing. So if you have a cart product, in this case, defined in your test, like a expected cart product, or test cart product that's got all filled out, you can actually put that in here and say, I don't just expect this to be called with just any cart product, I expect this exact object to be the thing coming into it. And when it is, I want to do this response. So in this case, we don't care what it is. Any cart product comes in, we're going to do this dynamic response, and we're going to expect it to provide a cart product in. So our lambda here up here, we weren't specifying any parameters. There weren't any. You could do this if there were and you didn't care about them, but we weren't specifying parameters. We're just making a lambda to run. In this case here, though, we're telling it, hey, we want parameters, and here's the typings of the parameters coming in, so you can have multiple parameters matching the signature, and then you can pass them in and return something. So here we're just returning the result from it. And then so after we would do these things and we would run a test that does stuff on it, we want to know if it actually did anything. So we could do things like this for dialog service, and we could verify that the service display alert async was called, and was called with these explicit values. So and it was called one time. So this might be somewhere where, you know, there was just some sort of error. We want to test, this is what happens when the API couldn't add it because you're offline or something. So we want some sort of response going back to the user. And because we have our dialog system implemented in an interface, we can verify that, hey, the service was called with these exact parameters and one time. So let's take a look at that. So here's the mock. This is kind of the code around what that's based on. So we have an interface, just got clear items, all items, get items, and update item, and then our cart item defined. And here we're doing our various setups. So this isn't a unit test because I'm just running it ad hoc, but same behavior here. So we create a cart to hold our list of carts. And so you can see here, this is actually kind of making a working mock system. So you could define things entirely static, but if you wanted to make sure that multiple steps maybe work the way they should, you can put the pieces in here. So like maybe the cart repository is, or the service is doing something before sending it to the repository. So we want to make sure that the data that's processing data properly in the service layer. So in this case here, you know, clear all items. We're actually going to clear our, we're just going to return the current cart back out of it. It's actually not a very good way to do that, but that's what we're doing. This works here because this is static, so it's always going to be this value. We're going to set up the items, you know, similar things that we showed before. Here, we're going to do something a little bit more special with the update item. We're actually going to try to find the item in our collection, our cart that we've had. If it's there, we're going to update the quantity on it to whatever was passed in. Otherwise, we're going to add it, and then we're going to return our cart because that's what comes back out of it. And then this is actually getting our object we can test. So we do the mock.object, and that gives us our actual typed instance of the thing we're mocking. And then we can just make calls on it here. So we can go through and do all the calls, see the things that happened on it here. And because I should clear my results first. We can see all the calls that we make here. And then we can verify down here that get items was called exactly twice out of this, which we know it will be because we're calling it there. If we run it, you can see all the outputs from it here. It's actually doing some dynamic work. So if you need something that's, you know, actually does some functionality, but it's not the real functionality, it's mocking some layer, you know, you don't actually want to go to the repository, but you do want to do the behavior because maybe you're doing something that relies on making a call to the repository and then doing something with the results and making another call. You can set those things up and it very flexible on what it can do. So mocking things, you know, get us away from concrete types and being coupled straight to them for our tests and everything. But, you know, the question is, how do we get away from not just away from new and the concrete types, but, you know, get onto something that's more sustainable in the long run. So I want to talk a little bit about my TD journey with XAMARIN forms. So several years ago, I had watched, actually got to a talk by Jeremy Clark, who either has already done or is giving. I know he did a workshop. I don't know if he's already done his other talk at Code PaLOusa here, but he had a talk on TDD that really inspired me to actually try to do it. We kind of joked about this earlier in the discussion. Aaron and Dan and everyone talking about, how we either don't have tests or we have them and, then they get outdated and we comment them out, and everything and stuff. But I'd done that stuff in the past, like, oh, I'll have a test. I'll test this stuff. I put a few things in there and then it got too hard to maintain. But I was really inspired after his talk to really give it a try. And so, I was like, okay, I'm gonna do this. I'm gonna, do this thing. So I was like, okay, I need to do some mocking on my test, right? So I got started down that route of mocking things out, doing all the stuff I needed here. So my calls worked, and I've got this view model here, that loads things up and it takes the services in and, does all this stuff. And I'm got us all set up, and I'm great because my view model, I call load projects. I can verify that, it actually did the things that I expected to do. It actually fired off an event that it had on there that said it was going to do the project loaded event or edit project loaded event. So this is just stuff this is actually pulled straight out of some code and everything. So, real samples of actual methods and things and stuff called here, not the actual test entirely, but this is kind of where I started at. It's like, hey, I've got stuff mocked. This is great. But I'm newing my view model, putting that stuff in there. And, then I started kind of working on it a little bit because I got a new dependency. And I was like, oh, I've got to do all this setup on it. And I've got to, create this multiple times. So I was like, I'm going to take all these dependencies here, this nav service, mock event aggregator and everything. And instead of having them all right here in line, I'm going to move them into methods, make it easier to instantiate them and everything, and use them the way I needed to use them. So I grouped all that stuff together. And once I had that refactored, I went in and, was able to use it like this. I was just able to go in here and hey, get my aggregator, the thing I needed, pass it in here, et cetera, for these other ones, get all these default things to pass them in. And so I could still test it because I needed the mock, right? So I needed the mock coming out of it. So if you saw, these tests all return the mocked object out. So I was able to do this, run it. And so here's that test, with my new dependency in here, the file viewer service on it, but simplified, to where, great, I have a new dependency, but now I'm just going to, get the one I need, pass the others just straight through, pass this one in, then actually go and use this to do my validation afterwards. And this was good. This started making it easier. My tests now just pretty much look like this. But the more you do that, and you start realizing that, hey, I've got to create this, view model every test. I've got to do this part every single test I go through and everything. So, how can I make that easier? And do the natural progression. I made a method that actually did the newing for me, and I could pass in the service, the dependencies that I needed. And if I had them, then it would put them in, or if I didn't, then it wouldn't. So it made my tests a little bit easier, right? Now the only times I had to actually do anything with the parameters here was when I cared about it in my test. And this was much, much more manageable. I was able to go in there and say, hey, okay, test this, I add a new type to this, the new dependency that it has, but my test doesn't need it here. Well, that's cool. I just came back here and just added in this one method in all my tests that, we're doing this update. I don't have to go back to all, hundreds of tests or whatever on this view model and update each one to add this new dependency into it. I only have to create the new test that test that new dependency, and do something similar like this for those tests. Helped out quite a bit. Made me feel pretty good about my tests and what was going on there. But I still kind of looked at this and I thought, this is still a little cumbersome to do this. I still am having to explicitly call this, doing some extra work here. I just kind of started thinking about it, and I was like, what can I do to make this better? And one day it just clicked. I was sitting there, I was adding the type, and I was going and putting it into my IOC container, registering the type and going to use it. And somewhere in the process of doing that stuff, I sat there and I was like, oh, why am I manually, putting these pieces in over here and, doing all this work over here when I could be leveraging the same technology, the same functionality in my tests? What if I could create, instead of tests that look like this, it's not too bad, not bad at all. But what if instead of creating a test that looked like that, I could create a test that looked like a little bit more like this, where all I've got to do is, resolve the thing I want to test and call it, and then maybe just call a method that says, hey, make sure that, the thing I expected to happen happened. And I got to thinking about how I could do that and what it would look like. And so what I ended up with was something along the lines of this. And so I'll kind of explain this a little bit, but basically what's happening here is the order repository test here is inheriting test space. So my test space has some stuff that it does. And we're going to look at that because I want to show how this works and everything, and what I did to get this together. But it inherits that, and then all I do in my test is I set up some default creation methods. So I've got this order service mock creation that says, hey, would just call this method, passes in a mock, so it expects a mock of the iOrder service here to be passed in, and it's just going to do the setup on it for the get orders. And so I've got that. My constructor, I just say, hey, register a new mock type, and this is we'll look at this. This is a generic method, but register this type with a action that calls this method here. So the one I defined up here. So this is going to happen. Anytime I register the mock type, it's going to evaluate this, which is then going to run this. So it doesn't just get ran once; it gets ran every time that I need to get the object. And then my tests, just like I showed, is just real simple like this. I just ask for the thing, the order view repository, and it has an iOrder service, which we defined up here. But I didn't do anything else except for just ask for it to resolve this type. I just say, hey, give me one of these things, and it's using all the dependency injection that we normally use in the background to build this out, to figure out what it needs to have. It's calling these setup routines as needed to configure the object it returns, and runs the method on it, and then does the validation on it. So I'm gonna explain more of this as I go, but that's the general flow of it, and everything. So I have some setup. The underpinnings of this make sure that each time a test is ran, that the types that were in my IOC container are thrown away, and so I get a new set of them, which means I get things configured again, each time that I go through it. So I'm not using old stuff. Let's see. I actually want to back up, and I want to show some things on this before I get too far. So I'm going to show you how things are in the ease library, and kind of take you through the pieces of it and why and how it works. Get a chance to look at this, just looking real quick. I get a chance to look right after my other talk got done, making sure I'm doing the right thing. Yeah, so I'm actually going to show it. Let's talk about my library first, and then we'll talk about how it works. So, decided to take the things I put together and make it something that I could put out there. So this is built on other people's work out there. This is not a unit testing library of its own, but it's a opinionated way of using these things together. My goal is not to convince you to use Easy Library, but it's to show you how I did it. And if you want to use it, awesome. If you want to use the concepts your own way, that's awesome as well. But what I want really is to kind of share ways that we can make unit testing easier. But I built it on top of InUnit and mock. It now supports, because of community contributions, XUnit as well. And recently, basic initial implementation for MS Test is in there as well also. And for IOC containers, you can use Unity or Dry IOC. There's no reason we can't do others. That's the ones that I used, because I originally wrote this working with XAMARIN Forms and Prism. As you can see, there's Prism Forms integration, and so Unity and Dry IOC are the containers that they use for their IOC in there, the popular ones. So those are the ones that I went after, and the ones that I have in my various projects that I've got out there. And what I really want to do was just provide something that's simplified, using dependencies and mock dependencies, and made it easier to write code and make it easier to use the mocking and IOC containers together. So it really lets you write some code that's something along the lines of this. We've got a dry IOC container test base being used with our order repository tests. So we're using dry IOC. Now I need to update this because of the recent changes. This actually would be called InUnit dry IOC container to call out the specific testing technologies we're supporting. But it's really pretty simple. We define a on creation method. So in this case, for our order service mock, we have an on order service mock creation method. This is the method that's going to get called whenever we run a test. And then we're going to register the mock type. We'll look at what this code does here. But basically it sets things up in the container so that when a iOrder service is asked for, it creates a mock of that and then runs this setup routine on it. And then I do this little register per test setup. And basically what this does is, and this exists because, so in InUnit, it creates a test class and then runs through all the tests in the class. It doesn't keep creating the class over and over. It creates it once and runs through it. So the per test setup hooks into, when you're using the InUnit piece, hooks into the InUnit's setup attribute method. And each time a test is ran, it goes and runs this before the test. So what's going to happen is each time before a test is ran, we're setting our on order service mock creation equal to our default creation method defined right here. And so each time we start a test, this is what is going to happen when we resolve for a iOrder service. It's going to create the mock and it's going to call this method, which because of this is going to point to this actual method right here from the delegate. Hopefully everyone followed that. Raise your hand in the chat there. We may go in on it more, but I'll explain why we do that in the next slide. So this gets our default behavior set up. If we just ask for something using iOrder service, we know that it's going to return a new list of order for the get orders method, nothing in it. But maybe we have a test where we need to do something a little bit more specific. So imagine we had just done this for the iCart repository method here and everything. So instead of the order service creation, we had all this setup done for a cart repository. Well, in our test itself, because we're evaluating this delegate on instantiation, so it's not being evaluated here. It's not being evaluated here. It's being evaluated when we actually ask the IOC container for the iCart repository. And so since we haven't done anything to it yet on this test, it's all brand new, we're able to come in here and say, hey, for this test, I know that you had this other functionality that you're already doing, but for this test, instead of doing that, what I really want you to do is I want you to call this setup and do things this way. So instead of running the normal stuff that you might do, I want you to return a null back out of it. So I need to do a test that makes sure it didn't work right. So I'm going to come in, do that setup, and then do my resolve for the product detail page view model here, which depends on the iCart repository, maybe even a couple layers down, but depends on it. And it's going to create it. It's going to run this on it. And then it's going to go in and execute the add to cart command. And we're going to expect the update product to fail in this case because it returned a null. So we are expecting that we actually display an alert to the user that says, hey, we couldn't do this. And we display it one time. So it allows us to have a whole set of tests set up with default behavior that works for like 90% of the tests. And then for the off cases where we need to test these kind of conditions, it's very easy to go in there and say, hey, for this test, do it differently. Behave in a different way there. And then because of the support for Prism in there, we also have things in there that deal with some of the Prism stuff. So if you're doing Prism, whether it's in WPF or XAMARIN forms, you can come in here and we have helpers to deal with a lot of those. And this is actually expanded a lot due to community contributions out there. So here's a set of tests, showing some of this. So we've got a few pieces here. So I want to show this work. I'm going to comment out this line right here. We're just going to run our unit tests. So we're going to fire them off here. Let them run. And we see we get all greens on it here. Everything worked because we're coming here, we're registering our setup for this mock type. And, we're telling it to run this piece. We're registering the mock itself using that. And we're registering the type order service because we need the order service itself to resolve out of the things. We're just telling it, hey, this is what it is when you ask for that, just get the concrete type because we actually really want to test it. And then we're coming down here and we're expecting some certain things. So we're expecting here the get customer orders to return one item out of the order service. And we can see our default setup here. Look at it. Returns to us a array of orders with one order in it. We don't care about what's in it. We want to make sure we actually get the value of this and it comes all the way back out, all the way back to this. And so if we looked at our order service, we could see that the order service here, is taking in the repository and it is actually calling that method on the repository to get the value out. So we're going to get, whatever this has coming from it. And so all of our tests fail. Well, the reason why we do all this setup and everything is so that we run something like this. Our tests all still work because we redefined it. I'll show you what we did. We told it here that, hey, we return an array with nothing in it and everything. So we don't want to do, anything else to it. Well, the reason we do the per test setup is because if we take this out and we just define this once up here, if we run this test all by itself, we see that it passes because the state of everything's right. But if we run all the tests, just so happens it runs in an alphabetical order. And so this test gets ran last. And because we weren't doing the resetting on each execution of the tests, we're actually impacting tests by the one. So here where we changed what that delegate was pointing to this new method, now all the tests that ran after this one ran, which happens to be the first one that runs, I believe. It's really long test names. Yep. So it's the first one that runs. So every test after it's actually getting this result coming back from it, which doesn't affect other tests, but does affect this one here. So by being able to reset that on each run of it, we're able to run it through and have every test be in a good state the way we know we want it to be, doing the thing we want it to do. So the way this works is, so this is the in-unit dry IOC container base. And if we go take a look at it, we can see we're doing just a few simple things here. So all the IOC container stuff's wrapped up below this. So I tried to make this layered in a way where you could take the pieces that you wanted and use them the way you need them. But so the in-unit layer of this is all we're dealing with here, but it does a couple things. It's calls the register per test setup overload. So this is to set up its reset lifetime, and this controls the internal container stuff. So this makes sure that every time our test starts, reset lifetime, which is defined down in the dry IOC container, runs, which clears out all the stuff that's being held in it. And then we have our setup with our per test setup that calls the on per test setup method. And we have our register per test setup. And this is all this layer because this is the way that in-unit works. So in-unit needs this to be able to work right. So the in-unit layer actually has these pieces in it. And that's why it's defined here. If you go look at the X-unit layer, it doesn't have the same things. You would just put them in the constructor because the constructors ran every time for it. So you don't have to do, some of these things don't have to be done. So there's some advantages and disadvantages. One of the advantages on in-unit, because it uses the same class over and over, is we only have to configure our container once. So we don't have the container configuration hit constantly happening. We have it happen once, and no matter how much stuff we register in it, it's done and registered and built, and then it's reused and just cleared out each time. But so these pieces are all defined here. That does the setup on each test for us and runs through that. If we look at the IOC container base, it's defining a few things that are required for it. Obviously, it has a hard, tie to dry IOC because it is what it's designed for. But so it does all of its container creation, configures things internally to deal with resetting the lifetimes and dropping all of the stuff out. It's very easy to do with dry IOC. I first did this with Unity, and it took a little bit more work to actually do the clearing. There's not a scope context type thing built into it. And then we just have our register types, which, the regular one just registers it. This is to call like an order service itself. And then we have the register types for a interface with the implementation. It just says, an actual normal register that you would do. And then we have this register mock type, which, as we saw, expects to take in a function that returns an action of mock of whatever type we wanted to test, which we saw right here. That's what we're doing. This is an action that takes in a mock of of the iOrder repository, and it's being used right here in the register. This is a function that returns that, because we're not calling it, there's no parentheses here, so we're not calling the method, we're returning a pointer to the method here, returning the delegate to it. So it comes in and does some stuff to initialize it. So it configures up a factory basically for it so that instead of actually just registering the type, it registers a factory for the type, and each time that we ask for it, it runs the method, this method, which takes in our type that or delegate we passed in, passes it to it all the way in, and so this creates the mock, sets our created call back up, and if it was given to us, calls it. You could be doing this for something where maybe you have a test that depends on the type you're testing depends on a certain interface, but none of your tests actually use it, so you wouldn't actually define any kind of implementation. You could pass null in all the way down, and it would skip it, and then returns the mocked object out. So you might ask, if we're returning the mocked object, right? So this is actually an instance of T. So this isn't a mock of T. This is T coming back out. Wondering how is it then in our service test that we come down here and do our validation? Well, we have a routine in here to do validation, which is defined all the way down in our most base pieces, and it's really pretty simple. But the mock stuff allows you, if you have a type that was created from a mock, so like an object that was created from a mock, they provide you a way to get back to the actual mock itself, so that you can run all the methods from the mock interface or the mock type on it to do like a verify or other things like that. Just like you would for the configure, they'll let you do it for validation at the end to make sure that something was called or other things like that. Okay. That, in a nutshell, is Ease Library. It's the way I do my unit testing now, and everything. It's got support for, like I said, Unity and DryIOC. Also, like I have NuGet here. It also has support for XUnit and MS Test. And really, like I said, what I wanted to share was the way that I do this. So if you want to use Ease Library, that's awesome. Love to hear your experience on it, and give me feedback on the repository and everything. Hopefully no issues, but if you find issues, let me know. If you see enhancements or want to get involved in it, let me know. Or if you just want to go and kind of snag what it's doing and pull it into your own stuff, it's MIT licensed, so feel free to do that. But I think that unit testing your code and leveraging IOC makes it much, much easier to manage. This stuff is kind of hard to see in some of these examples, but take those examples with the one method and then imagine hundreds of methods that are all using the standard setups, and now they're just simply subject equals resolve I subject or resolve my subject type, and then do my thing on it, and then do whatever validation I need on it. There's no tracking of objects or other stuff like that. All your setups configured up. When you're wanting to override or overload something, very easy to do. So thank you for attending. If you have questions or comments, drop them in the chat here. Love to get some feedback on it. I think it's actually right about time for the session to end, but I don't have anything after this, so I'm just going to hang out here and answer questions and see what you all have. But thanks for coming. It's, I imagine, a big standing ovation at this point. Thanks. If you have, thanks, Brad. If you have a question, drop down there. If you'd rather try to say it and everything, I think the options up there to request the ability to share video and mic, I can do that and let you drop in on it. Great, Seth. That's awesome. Love to have you take a look at it. I tell you what, I was so stoked when I got my first person asking to look at it and submit things to it, and actually found out people were actually using it, not just randomly downloading it. So pretty excited where it's headed. Trying to continue to improve it and do more things to it. So I found it real useful though.